Hello everyone. In the third video, in its last part, we were actually talking about the addition of vectors, and there we were speaking about the vectors which were either in the same direction or exactly in the opposite direction, or maybe those vectors which were at right angles to each other. We have seen some simulations for finding the vector additions. Now, in this fourth video of chapter of vectors, we are going to talk about, so here in this video we are going to speak about the triangle law of vector addition, that if at all I have two vectors of same type which are either in the same direction or in the opposite direction or even in any random direction, you can find what is the addition of vectors, and this triangle law of vector addition happens to be a fundamental law for vector addition. Now let's see here first of all what is the statement of this triangle law of vector addition. It tells you that if you have two vectors of the same type which are represented in magnitude and direction by two sides of a triangle taken in certain order, then their resultant is represented in magnitude and direction by the third side of triangle but taken in the opposite order. So this is what the law is going to state. Now here I must understand that the two vectors must be of the same type, because you cannot add displacement with velocity, you cannot add acceleration with force. So whatever or whichever two vectors you are adding, they must be of the same type. That is number one thing. That is why this word becomes very important, that two vectors of the same type. So if you have two vectors of the same type and they are represented in magnitude and direction by the two sides of a triangle taken in certain order. What do I mean by this? So here this diagram actually shows me that I have got two vectors here. One is vector A, the one which is shown in this red. The other is vector B. They are placed in such a particular way that wherever you have the end point of the first vector, that vector B starts from the same point. So the resultant or the addition of these two vectors is given by the third side of the triangle, but now in the opposite direction. Here in this first diagram I find that this vector A and vector B, I observe that they are in the anti-clockwise sense, so the addition will be in the clockwise manner. So that is what I find. Whereas if you have if you observe the next statement here, that addition of two vectors is always following a commutative law as well as associative law. We will speak about that commutative and associative law a little later, but before that we will go for a very nice simulation of vector additions here. That I have got two vectors here. If you see on my screen right now on the video, I have got one vector A here. Now this vector A, I just find that this vector A is taken here and it is found to be say it will have some particular values of A and B. I would take its values to be let us say equal to 6 units along the x-axis and 8 units along the y-axis. In fact, this vector A here in this case is going to be 6i cap plus 8j cap. So this vector is vector A, the magnitude of which will be equal to 10. But anyway, I do not bother about what are its directions, and then I will just take my vector A to be anywhere over here. So this is my vector A, and there is some other vector over here, that is vector B. So I have got two vectors, one is vector A here, the other is vector B here, and I want to find what is the addition of these two vectors. And then the addition of vector A and this vector B is found to be given by this third vector called as vector S. Now whether this particular logic is correct, I have to try and use this, whether my vector addition law, that is the triangle law of vector addition, proves this particular thing to be right. So I'll take my vector A, mark it somewhere here, I'll take my vector b as we said it in the triangle law, that you must have your vector b should start from the end point of vector a here. So this is vector b. Then the resultant of a plus b is given by the starting point of the first vector to the end point of the last vector, that is starting from this point here and ending up to here. So this s has to be equal to that if s is equal to this, it has to match with this, and it is actually matching. It's like the third side of the triangle. If you even try to find what are the values of a and b vectors, I'll just take them separate or make them separate. If I go for vector a here and its value, its magnitude is 10 units, its you can say x and y components, they are represented for vector a as vector ax is 6 units, vector ay is 8 units. So as we said it earlier, you have vector a is represented as 6i cap plus 8j cap. Whereas if I have a look at this vector b, once again it is also found to be of the same magnitude, that is 10, but this time you have x component of vector b is equal to 8 and y component is equal to 6, so that this vector b is represented by 8i cap plus 6j cap. Now listen to what I am saying very carefully. This vector a was represented as, as I say, I'll just take myself you see up a bit here. So this vector a is given by 6i cap plus 8j cap, whereas vector b is represented by 8i cap plus 6j cap. And if I want to add these two vectors, the x component will get added with x component, y component will get added with y component, that I cap and I cap will get added up. So this 6 and 8, they will get added. It will make 6i plus 8i is 14i cap, and y components also will be getting added. It is 8j cap plus 6j cap. So it will be 8 plus 6 is 14 here. So your resultant vector here is the one which is shown in this blue vector format. It is actually, in terms of vectors, it is 14i cap plus 14j cap. Now whether it is right, I can just take this vector to origin and I can see if it's matching. So it has to be 14 units along x-axis. Yes, it's 14 units here. And it has to be 14 units along y-axis. It is 14 units along y-axis. So that's how I can have this. If at all I want my you see vectors to be shifted a bit, maybe if I take it and I shift this vector a to be somewhere here, I change it here, and I take my vector b here and I take this vector b, change its direction to be somewhat like this. Now what is vector a plus vector b? According to the law, it says that a, wherever it ends, you have to take it as a plus b. So this is going to be equal to the vector starting from the first point of a to the last end point of b. That will be representing your vector c, the addition of them. Now let me actually try and find. This is my vector s, is the sum vector, and that vector is supposed to match from this first point to the last point, and it is matching. Now what I just do is, I'll try to find what is vector b plus vector a. I'll remove this sum vector. I'll take vector b here. Maybe I'll just keep it for time being. I'll try to see what its values are of you can say this blue vector. I'll try to find out, and for this sum vector I find that it is 15i cap plus 12j cap. Whereas what was my vector a here, then I find that vector a is 11i plus 4j. This is 4i plus 8j. So the addition of these two vectors happens to be 11 plus 4, that is 15i. This is 4 plus 8, that is 12j. So 15i plus 12j is this particular vector. I have also shown you by using this you can say values here, that the sum of the two vectors happens to be like this. Now instead of this, I'll try to take vector b plus vector a here, that b is here, and I'll try to take vector a at the end of this. Now what I will be able to have is b plus a. Now if a plus b was earlier given by this, now this b plus a, if it is same, it has to match with this point to the last point. So I'll try to find this out, and as I take this vector here, I observe that it fits exactly. So this is what I actually understand by saying that the vector addition is commutative. So this is how I can go for understanding the vector addition, and this is what your triangle law of vector addition is. Instead of having two vectors, I can also try and add three vectors, but of course that will not be possible by using just a triangle law. You will have to use triangle law multiple times. It is also called as polygon law of vector addition. But of course I can take this vector c to be somewhere here, that if at all I take vector c somewhere here and I try to take this vector here, then it will give me sum of a, b and c, that will be given here somewhere. So if you have vector a is here, it's you can say here it is 11 plus 4, 11i plus 4j. B is given by 4i plus 8j. C is given along x-axis, it is 6, but along y-axis it is going down, it's minus j, 8j. So you have got three vectors, 11i plus 4j, the second is 4i plus 8j, the third is 6i minus 8j. So if I add all your x components together, you will find that it comes to 11 plus 4 plus 6. So 11 plus 4 plus 6 has to turn out to 21. Whereas, so it is supposed to be the resultant, the addition of all these three has to be 21 I cap, it must have, or 21 along x-axis. However, about y-axis addition, I'll find it is 8 plus 4 minus 8. So it's ultimately going to be only 4 along y-axis. So the resultant vector, sum of all of them, it has to be 21i plus 4j, which you see here, it is seen to be something like this. I'll just shift this up a bit, and I find here that addition of all of them happens to be equal to 21i cap plus 4j cap. Now whether I can just keep on adding vectors one at the end of the other. So if I try to do so, I will be able to understand here that the sum vector, of course we had, that this is my vector A, I'll shift it here somewhere. This is my vector B, which I put it somewhere here, and this is my vector C, which is taken to the end point of B. So from first point, this is A, from here to here it is B, here to here it is C. Then the resultant is supposed to be A plus B plus C vector is supposed to start from the first point of A and till the last point of this. So if this is a sum of all of them, it must match with this, and it is actually matching, if you see. If you even change their, you see, pattern A, B, C, if you take B plus A plus C, if you take it like this, maybe if I take B here, if I take A here, and if I take C here. So B plus A plus C also has to be the same thing. So I'll just see, and yes, it matches. If you take C plus B plus A, I'll take C here, you take B here, maybe C plus B plus A is taken somewhere here, and the resultant has to start from this point and it has to reach till the last point, and if I try to do that, it even matches. So overall, my observation is that vector addition is commutative and vector addition is also associative. Even if you change its you can say order of vector addition, you will find that vector addition values, the resultant of vector addition continues to remain as it is. So this very superb animation has shown you how can you add vectors, and I hope this should help you to understand this triangle law of vector addition rather than just you see studying the statement. I have shown you by several examples of the vectors of how can we add vectors by using triangle law of vector addition. In the next video of ours, we will be speaking about the parallelogram law of vector addition. Thank you very much.